Another important use for calculus is to find, as well as finding stationary points or turning points, but stating their nature. And this we had a look at last year briefly, but this year they complicate it more. We're going to have a look at just how to do it, and then of course you apply the chain rule, product rule, quotient rule. Okay, so we want us to find out where the stationary points are of this function, and it wants us to state their nature, whether they're maximum or minimum. So we're going to have a look at this thing, and the first thing we're going to do, we're going to differentiate that. So we're told that f dashed x will end up being, let's write that better. I've lost my stylus, so I'm using my finger. Alright, so f dashed, start it again, f dashed of x equals 9x squared minus 4. So we want to find where they are, so we're going to let our derivative equal 0. So 9x squared equals 4. So then we've got x squared equals 4 over 9. So x equals plus or minus 2 over 3. So that's our points. That's where we know we've got stationary points. Now, we're trying to find if they're maximum or minimum stationary points. So what we do with that, we need a table. We have a table with x. We have a table with f dashed of x. And then from there we have a gradient, what it looks like. So what we're going to do, we're going to pick these two values and some extra ones. So we know that at negative 2 over 3 we have a 0 gradient, and then at 2 over 3 we have a 0 gradient. What we need to find a value that is on kind of both sides, but either side of this and either side of this, to give us an idea as to what it is. So I'm going to choose negative 1, 0, and 1. So based on that, I'm going to substitute negative 1 into the derivative. So f dashed of negative 1 equals 9 minus 4, and that equals 5, which is positive. Positive, so it looks like that. At 0, I know the graph looks like that. So f dashed of 0 is negative 4. So I know that we're going to have negative. So it's going to go downwards. Once again, at 0, it's flat. And then f dashed of 1 equals 5. So once again, it is positive. So it's going to look like that. So overall, our graph will follow this kind of pattern. Up, flat, down, flat, up. So with two turning points there. So we're asked to sketch it. And it's going to kind of follow that pattern. So I'm going to have a turning point here at negative 2 and 3, then another turning point at 2 and 3. And what we do, we just go something like that. Now, when we're sketching graphs, remember to find your intercepts, value of intercepts, values of turning points, which you can find just by substituting in values and doing whatever else you need to. But to go over that again, we want to find stationary points, we differentiate, let the derivative equals 0 and solve for x. Oh, I haven't actually said 9 squared x minus 4 equals 0. Make sure you put that in. Once we found our two values, we put them into a table. And then we choose values on either side of these. So I'm going to choose one which is less than negative 2 and 3, one which is more than negative 2 and 3. Coincidentally, 0 is less than 2 over 3, and then 1 is more than 2 over 3. So we substitute those values into the derivative to determine if the derivative is positive or negative. So from there, we substitute positive, then we draw a little picture underneath in the third line. So if it's positive, well then it's increasing. If it's 0, it's flat. If it's a negative, it's decreasing. 0, flat, positive, increasing. And when we use this pattern to draw out our graph. And then when we're asked to sketch a graph, like always, show key points by evaluating for them.